Okay, well, good morning.
Fine.
We're gonna do a couple more videos today of a fella that actually works out in the field, digging up dinosaur bones. And he has this place where he brings all of the interesting bones to and whatnot. He's gonna talk to us in a couple of movies, videos today, regarding what his ideas are and what he sees out in the actual, what he digs up and where. And some of the things about that, so. Are more with him, he's not the most energetic like we've had on some of them, but he does know what he's talking about apparently. So we'll go from there. Yesterday we had a great time here with, as far as the canning goes, um. Dan did a nice job. Of doing stuff, so if you missed it, couldn't record it, so sorry about that. But we'll try and get him to do it again sometime, maybe in the fall. That would be nice to do because come and see how you can make a beef stew all in one can. So it was fun. Had a good time.
Could I ask a question?
Certainly.
I saw canning jars out there yet, so those, nobody wanted those.
Correct, but we have homeschoolers come through here all week long, and I was just gonna put a free tag on them, unless you wanna take them.
No.
Okay.
Wonderful.
Okay, yeah, I was gonna just put a yours for free, and I'm sure that there's some homeschoolers that homeschool parents that those probably be gone.
Yeah,
The great big 2 gallon ones, those are big ones. Dan says, boy, he said, I'd like to take those, but I don't. I can't, he says, cause he cans milk. So
Those would be good for dry storage.
that's a hint. She kind of looked side-eyed towards you, Dennis, so.
Well,
Make sure.
Huh? There ain't any such thing. Come on.
No, I'm good.
You're good?
Yeah.
Okay, take it under advisement then, Dave.
Thank you, thank you.
Oh, you're very
for
welcome.
that.
Thank you for
Friend
bringing
is
them in.
moving and you get rid of stuff.
Yeah, yep. So, it's good. A big pickle jar, yes. So, all right, let's get started. Start off with a word of prayer. Our Heavenly Father, we thank you, Lord, for this time, for this, these videos that we can learn about your creation, Lord, and what you did during the flood to give us what we have today. We ask for today's worship service that it be pleasing in your sight, and that our hearts and our minds are open to what you want us to hear today. We ask all of this in Jesus' name. Amen. Now, Jim and I have been talking about how many videos how many more you're up for on some of this. I mean, there's some that I talked to him, I said, boy, it's an awful nice one that Danny Faulkner, who actually went down the canyon with us. He's a PhD astronomer. But he has some interesting things about our solar system and some of the facts that I didn't really know about how our moon helps the earth. So he goes into that. So I know I'm thinking that we should do that one, absolutely, because he talks about, all of the questions and whatnot that we've all had about things. Some very interesting things going. So we could go on probably for another 6-7 weeks with the videos that we have, but we don't want to overdo it and say, but I think there's enough difference of things that we've presented so far. And then at the movie at the very end, not sure what we're going to do there because it's just below 2 hours long. So I'd hate to really break it up. Maybe we'll do a social or something like that in here and have food brought in and whatnot to actually watch it all in whole, because it goes over a lot of stuff. So, well, without much further to do, we'll get into the first one here. Let's get it set up. Is this one I gotta share sound this time? and go. And yes, Dell is in it. No. So,
So Art, this is where all these bones end up, huh?
Yes, after we come back from the field, this is where the
Oh my goodness sakes, what in the world?
yeah, this is a very large Triceratops. These are the two brow horns,
Yes.
and this is the nasal horn here. And actually, it has a nose that projected over a foot beyond that. So the total length of the skull from here to the back is about 7 feet. So that is a huge skull.
Art, this is amazing. I mean, this is huge. This is where you classify all the bones?
This is where the bones end up being stored. And for example, these are sorted by size. So these are small vertebrae here, down to little tiny ones like that. And these are from a variety of species, but the predominant species is Edmontosaurus, the duck-billed dinosaur.
Okay.
And these are tail vertebrae from a little farther forward. These are all vertebrae right here. This section here is the hand. This is the wrist bones here. And you can see they're really unique, and they're wonderful bones to find because almost always they have integrity. They're very large. This is the bone of the wrist. This would be equivalent of the back of your hand, yeah. These duck-billed dinosaurs had quite robust front limbs. They didn't walk on all fours. They probably ran on 2 feet, but they had the ability, their front limbs were strong enough to support their body.
A little bit like the kangaroo.
Yeah, kind of like a kangaroo. These are the terminal phalanges. These are called unguals. So
The very
that's
end
just
of the-
like each of the ends of your fingers. This would have been from a toe. These projections are where the tendons attach that allow your
So they're-
fingers to
okay.
move. And then down here at the bottom, I won't pull it out, but there's the metatarsals. That's the bones in your foot.
That's hard to imagine, isn't it?
It is. But while we're over here, let's take a look at these bigger bones.
These are massive.
These are the tibias, the lower leg bone. And
Just the lower leg?
most of these are from duck-billed dinosaurs, yes.
Huh.
This is a very beautiful example. It's got a lot of integrity. This area of the bone is usually crushed because of the press of sediment. So
Is that because it's more hollow here?
it would have had more space in there. This is a ulna, so that would be the lower arm. It gives you an idea. This is a large one, but it gives you an idea of just how big these animals were. This one's unique because it has a tooth mark right
Is
there,
that right?
where some tooth got caught in it, and you can see the drag mark coming out of it.
Is that unusual? Obviously, you're pointing to some sort of a battle that was going on.
More likely, it's scavenging.
Scavenger after they're dead. All of these bones have come from the Hansen Ranch.
That's right. These are all from that one site.
Do you have any idea how many?
Well, we have upwards of 20,000 in the collection.
And how long a time has it taken?
It's been over 20 years.
Is that right?
Yeah.
This has been your life work almost.
Well, I didn't plan it that way, but that's how it turned out.
it's turned out that way. Wow.
Over here on the table, we have a couple of femora. Those are the upper leg bone.
These are monsters.
They are. And that's the longest bone in the body, and usually the largest. And these weigh a couple of 100 pounds. So you can imagine you take one of those large tibias that we
Yeah.
just looked at, add it to this, and you're dealing with over here somewhere, and then you've got the foot below that and the hip above that.
Just hard to imagine.
These are really big animals. This case has the remains of Nanotyrannus. Nanotyrannus is one of the rarest dinosaurs, and these
Is
are
it, when you say Tyrannus, so is this similar to the T-Rex?
similar to T-Rex, and there's a big dispute in the scientific community about whether it is T-Rex or not. So the problem is there are no juvenile T-Rexes, or if there are, they're very, very poorly understood, very poorly known. So you can't have a dinosaur that's 30 or 40 feet long without having something smaller. And so they said, well, this must be a juvenile one, but the characteristics don't match with T-Rex.
So
They
you
have,
see them as fairly different.
it's a different taxon, yeah.
What do we have here? This is
This is the
teeth?
this is the upper jaw, and then the lower jaw is here. This happens to be from the other side of the body, but you can visualize this. So it would have been a fearsome animal.
It would. It's the kind of animal I think I would run from.
Here's the tooth, and that brings us to teeth. These teeth are very important because one tooth can tell you a taxon. So if you find a single tooth, you know that that particular kind of animal was there because you can identify the teeth.
Oh.
For example, well, let's just take this one. This is a Tyrannosaurus rex tooth.
And how do you know that?
It's massive crushing tooth. It has serrations on the edge, and it's bigger than it could be in any other dinosaur that's around.
Yeah.
And that's a Tyrannosaurus, and here's a Nanotyrannus for comparison. And you see how that's blade-like, and
Oh, it
these
is, yeah.
serrations line up on the front and back of the tooth.
Uh-huh. It's a very
And-
different tooth then.
And this one,
With it.
yeah, this is a crushing tooth. And when this thing bit into bone, the teeth would break off sometimes. And that's okay for the dinosaur because he has an infinite supply. A new one
Is that
will grow up.
right?
Now, the fact that we find so many of these associated with these duck-billed dinosaur remains suggests to me that after they died, they were available for scavenging for some time, long enough for tyrannosaurids and other animals to be able to get in and enjoy the feast. Now, this drawer down here has a bunch of unique stuff. Grab that side. Let's just-
Okay.
These are the mostly non-dinosauran materials. You can see here are shells. Here's some dinosaur eggshell.
Oh my goodness.
These are scutes from the skin of a crocodile. Really beautiful fossils. And we have a lot of turtles in the site. These are all water animals. This is a example of a turtle shell. And you can see on the inside we have the rib cage. Turtles are unique among all the animals because their pectoral and pelvic girdles are inside their rib cage. So in order to develop a turtle, you would have to figure out a way to move its pectoral and pelvic girdles inside its
it
rib
seems
cage.
backwards, doesn't it?
It just can't. It's a real enigma for evolution.
Art, that brings me then to another question, and that's associated with the layer that you were finding all of these in. Was it called the Lance Formation?
Right.
Is that correct?
That's the unit.
And if I remember correctly, it's not as if these bones are random, it seems, that there's some sort of structure. What does that show you?
Well, this certainly is what's called a fossil graveyard. It's a place where many hundreds or thousands of dinosaurs or animals died. They didn't die where they are because I think we've discussed already they were transported to
Yes.
where we find them. But they died somewhere, and they were catastrophically killed. They all died about the same time because the bones are all in about the same shape. And so we have this massive number of bones, and there had to be some event that was significant enough to kill that many animals all at once. So that certainly brings up the idea of a global catastrophic process. Bone beds that we find in the fossil record are really much more pervasive and extensive than they are today. You can get a bone bed if you have, for example, a catastrophic flood and it covers an area where people and animals live. Then if you came back years later, you'd find some bones there, but you wouldn't find anything like the scale that we find in the fossil record. When you find a bone bed like these, and there are many of these in the Cretaceous, it certainly pushes you to the conclusion that there was a major catastrophic process going on. This is not just life as usual.
And that layer that you're finding these bones in, if I remember correctly, we were talking about how that appeared to be more of a mud layer. Is that right?
Yes, this particular place we have the bones in a clay stone to mudstone, so it's very fine material. In other places, they're found in sandstone. So there are a variety of different sedimentological environments you find bone beds in. This one we're very fortunate because it's easy to get the dirt off because it's not rock, it's unconsolidated sediment. But you still are dealing with massive numbers of animals being killed.
How big is that formation?
Well, the Lance Formation extends most of the way across Wyoming, and then it goes into South Dakota, and the name's changed to Hill Creek Formation, and then it goes into Montana, and so South Dakota, Montana, Wyoming, and then there's an equivalent formation up in Drumheller in Canada where they find the dinosaurs up there. And they're also finding these same dinosaurs up in Alaska. So we're talking about a large part of North America.
So this one is extensive on its own.
This is an extensive Upper Cretaceous bone bed, yes. And there are many of them. It's not just one, but they're not connected. But there are many bone beds in the Upper Cretaceous. That means these layers are strata that we call them. These are the layers like you saw in Grand Canyon where you have one unit that has some integrity and also has some extent. And those layers are one above another. So if you go down farther, you'll find another layer. And then you go down farther, you find another layer. And these have different kinds of fossils in them all through the geologic column. Wherever you find fossils, the same question arises. How did you get all these fossils there? And how do you preserve a fossil? And what kinds of processes are involved in fossil preservation?
Art, it's obvious that what you are doing there at the Hansen Ranch is digging in a huge mortuary. I mean, it's a huge deathbed.
And that's what taphonomy is about. Taphonomy is the science of finding out what happens to an animal from the time it's alive until it's excavated. So it includes the cause of death, what happened after it died, did it lie around and decay, or did it get buried quickly? And the evidence that it got buried quickly is the preservation of the integrity of the organism. Now in the case of these dinosaurs, their original death was followed by a period of time during which we assume they were scavenged and where they were rotting. And then after they were pretty much rotted, maybe a few days or weeks or even months, the whole mass of bones was picked up and transported out into deeper water and buried. And that burial is what preserved the bones. That's indicated by the fact that these bones are all separated. If we find a whole dinosaur that's still together, we know it had to be killed and buried in very short order. And to bury an animal this big requires very rapid burial. For example, we were studying whales down in Peru.
Yes.
And whales are pretty big animals. So when you find a whale that's been buried quickly and all its bones are still in place, you know that there was sedimentation, the dirt that covered them up was coming in very quickly. These whales still have the baleen in their mouths. The protein that comes out in just a few days is still in their mouths. So we know they were buried quickly. And when we wrote this up in scientific journals, we drew people's attention to the fact that this was rapid burial.
Well, Art, the dinosaur fossils that we're finding, you say that they are pretty much found in the same layer. They're not found throughout that whole system of layers. Give me the perspective of that.
Okay. In the Cretaceous, we find specific kinds of dinosaurs. We find these duck-billed dinosaurs, we find Tyrannosaurus rex, we find dromaeosaurs, raptors. That's typical of what you find in the Upper Cretaceous. If you go into the next layer down, the next set of layers down called the Jurassic, that's where they got the name for the famous dinosaur movies, that's where you find these big patasaurids and the other long-necked dinosaurs, and some other typical kinds of dinosaurs, including the Stegosaurus. And then if you go down below that, you find some dinosaurs that aren't so familiar in the Triassic. If you go down below the Triassic, you'll find other layers of rock, and these kinds of layers of rock don't have any dinosaurs in them. They have some reptiles, and if you go down a little farther, there are some amphibia and fish. And we get more and more marine as we go down in the layers until finally what we have at the bottom is entirely the kind of animals that would live in the ocean. So this whole scene from bottom to top is an orderly distribution of forms of animals. And that's the fossil record.
Well, let me take you back to the dinosaurs then for a second,
Okay.
because one of the big questions, again, was what caused all the dinosaurs to go extinct? You mentioned the asteroid, but now let's talk about from a Genesis paradigm. How do we explain that?
When we look at the fossil record of dinosaurs, we find that they are killed off in layers also. We have the Triassic kinds of dinosaurs here, and then we have the Jurassic kind of dinosaurs higher up, and then we have the Cretaceous kind of dinosaurs at the very top. And right at the very top, we find Tyrannosaurus rex and these duck-billed dinosaurs and the kind of things we're studying in Wyoming, because we're just right below that layer which ends the Cretaceous. And so I think this process of burial couldn't just be explained by a single asteroid. It has to involve something, dare I say, much bigger than that, and certainly on a grander scale that encompasses the whole Earth. And we find evidence for this in the direction of currents that are flowing over the surface of the Earth. For example, in the rocks, if you've ever seen cross-bedded sandstone, it's sandstone that lies at an angle like this. That sandstone tells us which direction the current was moving that deposited that sand. If we look at these flow of currents over the surface of the Earth and in all these different layers of rock, from the Cambrian all the way up to the top, we find out that it seems to be going the same way over wide areas of the Earth. Like there's some kind of flow taking place that's different from anything we have today. Today we have a basin, the sediments go into that basin from all sides, and we would see evidence of currents flowing into that basin. In the fossil record, what we see is the currents tend to ignore the basins. They tend to go right across the basins, and they tend to be looking at something much bigger than just a part of North America, for example. And in fact, the currents in North America and South America behave the same way, just to give you one example. So that to me suggests that in the development of the fossil record, we had processes going on that were bigger than anything we can imagine today. It doesn't say today's processes continued over a long period of time would have produced this. It says the only reasonable way to produce this is to have processes that are not going on the Earth today. When you look at the rocks themselves, you don't see evidence for the passage of a lot of time. And Dr. Brandon and I have been working on this for the last 15 years, just going through tens of thousands of meters of sediment, looking for evidence of the passage of time between the layers. And the evidence would be that the layers have been disrupted or resuspended or moved around by organisms or roots or whatever processes. Once you deposit a layer, if it's just sitting there for a year, say nothing of 100 years or 1,000 years, that layer is going to be affected by its environment.
So in the current process today, if we have some sediment that gets laid down, what you're saying is that there are processes going on that would radically change that layer.
Sure. Roots penetrate soil and move it around. Organisms, if it's, well, even above sea level, but below sea level, you have worms that live all over the bottom and other organisms, and they're burrowing constantly in the sediment. That's where they get their food. And so if you bring in a new supply of food for them, they're going to devour that, and they're going to mess up all the internal structure. So we look at these layers and we say, is the internal structure still there, or has it been disrupted by organisms, which equals time? Not a lot of time necessarily, but time. If you see no disruption, then you're going to have a hard time explaining that sediment in a long period of time.
And what did you find down in the fossil
We
records?
found tens of thousands of meters with no disruption whatsoever. One layer after layer after layer after layer. And we were looking at it in a centimeter scale. We were walking through thousands of meters of sediment, looking at centimeter level disruptions. And they're very difficult to find. You can find them once in a while, but not the kind that we would expect if there'd been the passage of a lot of time.
begs the question for me anyway, that, why would God not have dinosaurs today? What were the purpose of them? Do we find it in the Bible, about I mean, I know that it's said in Job about the Leviathan, which means big animal, but really there's nothing else that I'm aware of that they talk about dinosaurs back in, the big, huge,
It mentions that their tail was like a tree,
right,
so.
Which-
it's very large.
but it's very seldom mentioned,
Yes.
so, I mean, it's just a couple of times, so you can see it, but I don't recall any animal that could become that. I don't know. I mean, I guess that's a question we can have for a discussion when we meet our maker. As to, okay, tell me about the dinosaurs.
Well, it
Where,
seemed like
when, and
there
how?
wouldn't be enough room in the ark to have,
Well, there
That
certainly
many.
wouldn't be, but they must have grew out of something,
yeah.
you could have the smaller part. I mean, that's what went on the ark was, two of a kind that created all that, which there's another one that we'll show at another time that kind of discusses that.
So maybe when we remade the earth, we didn't make enough food to eat.
Could be. Or you just didn't put them on the ark.
These Brontosaurus needs a forest.
Yeah, that. Yeah, I mean, I don't know. Lots of questions.
If you're, if it is,
Yes.
where's the Hanson Ranch? Where's it?
It was in Wyoming he was talking
Okay.
about, the Wyoming one, and then it extends into Montana and other states, the Dakotas,
You-
all that huge long up into Canada, over in them, and they're finding it in all the continents. There's not just dinosaurs here, there's other continents that it's on as well.
That ranch is just like somebody stumbled on these huge bones.
Yeah.
And so.
Kids out there playing, or they're plowing or something like that, and say, wow,
Playing baseball.
boy, this looks, yeah. Make a good bat. Some of those, I mean, just one bone, couple 100 pounds. I mean, can you believe the behemoth on that kind? And that's just the bones. That's not talking about the hide and muscles and
Makes me want to see Jurassic Park come true now. Let's
Oh.
go.
they're trying, they got that dire wolf now, which
Okay.
I don't believe is actual, but
As long as they keep it on an island.
and you're not anywhere close to the island, right? Yeah, well, yeah. Don't take your kids there.
I might do that.
I don't know, she looked at you, Dennis, when she said, maybe husbands too. Exactly. Okay, this one's, talks a little bit more about it. Let's, see what he has to say.
Well, Art, it's obvious there is a large variety of living creatures that just got buried all at once.
There are, and the range of fossils is amazing. We have fossil dinosaur eggs, fossil shells, fossil wood, scutes from crocodiles and things like that, seeds, just a lot of different stuff. So there is a almost unlimited range of fossils. Even tracks of animals are considered fossils.
Well, I've heard of footprints being
Footprints.
fossilized. Is
Yeah.
that what you're talking about?
Yeah, and that's what I have on this slab right here. This is a piece of Coconino sandstone, and you can see
Oh my goodness, you can see
tracks
the
just jump
the
out.
claws.
Uh-huh.
So this is a creature that's either just walking along or running or something.
Right. There are some unique features of their tracks that indicate that these animals were walking underwater,
Huh.
which is very interesting because this is normally thought of as a dune sand, a sand dune. And the Coconino is right in the middle of the rock record in the Grand Canyon. It's lower Permian. Dr. Brand thought, well, that would be a good place to look because these tracks are supposed to be in dry sand, and yet we think it probably was wet. So he began to analyze these tracks, and he found out animals don't make tracks like this in dry sand. In fact, if you get any tracks at all, they're just big smears, as you can imagine. But if you have wet sand or you have sand underwater, then you can get these distinct tracks that show the nice toe marks. Again, you can see these toes are really
Yes.
well displayed. And that's an indication, in Dr. Brand's study, that's an indication that they were made underwater. So here's a case where, and not everybody in the scientific community likes that conclusion, but it's a case where a creationist who believed in a global flood used that as a hypothesis to study to see if that was substantiated by his research, and it was.
I suppose it's possible then that the tracks we're looking at is a creature who may have been trying to escape.
Well, historically, it's interesting that these tracks were considered amphibian tracks, and amphibia live in water, and it was changed to reptiles after Edwin McKee, who studied the sediments in Grand Canyon, after he concluded that the sand was deposited in a sand dune in the desert, then suddenly all the amphibians turned to reptiles, and now they're considered to be reptile tracks. So there's a lot of latitude in interpreting trackways, but these certainly seem to be consistent with the sand being deposited in water.
Do you have evidence, or have you found evidence in the fossilized record of animals under distress? Are there animals and creatures that appear as if they just didn't die normally?
Well, there are a number of examples where you have whole animal skeletons in which the head is pulled all the way back and the neck is craned back like that. And it was thought for many years that that was because the skeletons were deposited in dry conditions. The animal died and the ligaments in the neck constrained the head, pulled it backwards. But more recently, scientists who study these things have discovered that no, it's a result of drowning. So when you find an animal that has its head pulled all the way back like this, it's because it's drowning. So there's a case where something has come our way, those of us who believe in the flood, as a result of further study, and it has indicated that these animals must have died catastrophically. There are other evidences as well. For example, in dinosaur nests, and there are dinosaur nests with eggs in them, and often these eggs will have a double shell on them. And that's normally should be almost non-existent because animals lay eggs with a single shell. But if you stress a chicken, for example, the egg, instead of being laid, will pass back through the process of laying down a shell a second time, and so you'll get a double shell. And that's an indication of stress. And we find a lot of these in dinosaur nests. We find a lot of these double-shelled eggs. So that's an indication that they were laying their eggs under stress. Now, one can only imagine what kind of conditions would cause a dinosaur to lay its eggs during a global catastrophe, but they have to lay them if they're producing them, so it would have to happen sometime.
And that brings us back to a different perspective of the flood that a lot of times we pass on to children, right?
Right.
It's like the gentle rain comes down and the flood waters come up. But this was a catastrophic event, and it was going on over a long period of time, long enough, evidently, for us to maybe consider that dinosaurs were stressed in the process of making eggs.
Yeah, I think during a year's time, which is the time during which Noah was in the ark, I think the conditions of the flood went on for some time beyond that. There were catastrophic events going on. But at least during that year's time, things happened very differently than the way we visualize them as children. There was a very complex world. That complex world came to an end in a very complex way. And this is why we find fossils in North America, in a layer of rock, and we find the same kinds of fossils in Europe or in Africa in the same kind of layer. And this is a global phenomenon. So the world before the flood, whatever it was like, was very complex, and the process of the flood was very complex. There were times when dinosaurs were walking around leaving tracks. And so the water must have shallowed and gotten deeper. There are also places where dinosaurs are leaving only front foot tracks, which means they're probably swimming. So you get a picture of a world that's very complex. A lot of things that we might not imagine happening were happening. And there was time for that to happen in a global flood.
Well, everything that we have talked about points to obviously a great catastrophic event, and that's what we read in Genesis. In particular, a catastrophic event that involved the kind of tumultuous processes that are almost unknown to us today. But the conventional paradigm would look at this layer that you're digging in, and they would say that those fossils were created a long time ago. What's the approximate age that the conventional paradigm would give to that?
These particular bones are cited as being about 65 million years,
Okay.
just below the Upper Cretaceous event. And geologists who want to believe that, they can find rationale for believing it. Personally, I don't think the data warrant it, and I think that the account that's given in the Bible is a better explanation for what we see on the earth.
What have you found that would cause you to then believe that the flood is recent and therefore these dinosaur bones are not 65 million years old?
That's a very difficult question because none of us have experienced 1,000 years. We have trouble grasping the changes in 100 years. And we're asking the question, could these bones be 65,000 times as long as 1,000 years? And we have no idea if a bone could still maintain all its internal consistency and even the structures of the cells inside the bones. And now, as you know, we're finding biomolecules inside these bones. All this is a challenge to the idea that we're dealing with 65,000 times as long as 1,000 years. We can try some experiments. We can take biomolecules, for example, and we can heat them up and cause the rate to be much faster, and then try to extrapolate that back to lower temperatures. And that's a fairly scientific thing to do. And when we do that, we get figures for how long a protein or DNA can last. It's nowhere near 65 million years.
Well, Art, you have spent a lot of time in digging fossils and analyzing fossils and so forth. The tree of life that we see in our textbooks and on charts and so forth, and we're taught, would say that all of these creatures, and even the dinosaurs themselves, all came out of one organism in the beginning and formed all of the creatures that we see today. What do you see from the scientific evidence that you have found?
I enjoy looking at the so-called phylogenetic tree. It just means groups that are related. So it's talking about the genesis or the origin of groups. And so you see these trees constructed in textbooks. These trees are constructed with branches, and out at the end of the branches are extant groups or groups of fossil organisms. But the branches themselves, the important part, that lead back to some other organism, are bereft of meaning. They're just a line drawn on the page. If this was a real sequence and evolution was the correct explanation for these diagrams, then we ought to see a continuous development of fossils all the way along the tree. But instead, when you're talking about ultimate origins of things, you'll have something question mark at the bottom very often, and then you'll have all these branches coming up. At the end are things that we know, either from fossils or that are alive. And where are the data? It's just not, it's not telling us anything. It's information depauperate.
And didn't, my understanding is that Darwin even recognized that there wasn't a lot of data that brought those things together.
That's right. It's not
Just not
there.
there.
and it's not going to be there. He thought that perhaps with more study in the fossil record, we would learn more about this. And you can see these cabinets around here are all full of fossils, but they aren't telling us anything about the connecting of one form to another. And so you really aren't learning anything about the phylogenetic history of life by studying fossils.
So it's easy to draw a line on a piece of paper and make you think it's there, but it's another thing to actually find it in the data.
And I'm sure that those who believe in evolution see these lines as concrete,
Yes.
but I see them as question marks, just conjecture.
Yeah. Now, the conventional paradigm would look at that and it would say that that represents different periods of time, vast difference
Right.
of periods of time, and therefore we're seeing these smaller creatures evolving into larger creatures. Is that what you see from a Genesis paradigm, and can a Genesis paradigm explain that?
No, I also have training, as I mentioned, in molecular biology. So when I look at these earliest forms that we find down in the Cambrian, it's very easy to establish that they're fully as complex as anything we have on the Earth today. There isn't an increase in the complexity at the cellular level. There are differences. There are certain complexities in form that are found in things up here that are not found down there. But these all have to do with locomotion, which involves movement from water onto land. And the greater complexity of organisms that walk around on land is obvious. That's why we have what we call the mammals. These are animals that mostly live on land, and they're more complex. They have arms and legs and fingers and toes. And if you're a fish, you don't really need those. So you don't have them.
Well, Art, I think a lot of us were taught that the life at the bottom is primitive. That's the word that was used, primitive. And so that's a little different than what you were saying. It sounds like it's really not that primitive.
When you look at the animals that have survived, like some of the brachiopods and others that are still extant today that are also found in the Cambrian, the lowest layer where we have these complex life forms, you can investigate how complex the animals were. And you find out that these animals are fully as complex as any animals today in terms of their cellular biology. It really makes it very difficult to believe in evolution when you find out how deep the complexity is inside the cell. And I think that's one of the compelling arguments that suggests that evolution can't explain what we see. And that complexity is found, and it's easy to demonstrate this logically, that complexity is found in the first complex organisms we find in the Cambrian. When you go below the Cambrian, you don't have these levels of complexity. In fact, other than some single cells and a group of fossils of unknown affinities, you don't find anything below the Cambrian boundary. But once you get into the Cambrian, even in the very lowest part of the Cambrian, you find not only representatives of every phylum, every major group of animals, but you also find diversity. You find many species of these different kinds. Trilobites, for example. And we happen to be standing by the trilobite drawer, so I can show you some of these. This is a Cambrian trilobite.
Oh, that's awesome.
It's clearly a member of the arthropods, the same group that has modern insects and crabs and other crustaceans in it, and the spiders. They're all part of this alliance that have a hard exoskeleton. And these organisms are very complex. They had a head, they had a tail, they had compound eyes, just like modern insects. They had swimmerets on the bottom with gills on them that they used for exchanging oxygen. They had antennae that came out the front. Very, very complex. And I'll show you, even though these are not from the Cambrian, I'll show you some of the other diversity that we have in these trilobites. Here's one that
that's incredible.
looks
What
like
is that?
it's well furnished for protecting itself. It's one of the Phacops alliance. And you can see these compound eyes. You can easily see the ommatidia, the facets of the eye.
Well, that's hard to imagine this is a fossil.
And there isn't any increase in complexity from the first organisms we have all the way through the fossil record. At the cellular level, now there are changes in complexity in terms of the ability to move. So these animals didn't have to walk around on land, and they didn't have just two legs like we do. So we require more complexity to move us around, but it's all a part of the aspect of motion. It's what we need to do to move efficiently.
Well, when we were in the Grand Canyon, and even Dr. Marcus Ross pointed out those Precambrian rocks, those layers. So what we're talking about now is the fossils that are found just above that great unconformity. Is that correct?
Right, that's exactly right. Essentially, you're going from no complexity to the full spectrum of complexity that we have today.
So again, the word primitive kind of prejudices the mind, doesn't it?
It
To say
does.
that these are very complex creatures.
They are, and they have the same complexity at the cellular level, and this includes their developmental biology, as modern insects do. We can clearly establish that line of logic. If you're going to try to explain the origin of life, for example, you have to have a way of explaining the full spectrum of complexity that we have in modern cells. Nothing short of that will do. So since the Cambrians, since these first organisms occur, we see differences in diversity, but we don't see new complexity.
Okay.
And the complexity we do see is related to the ability to move. So I think that shows us that whatever is behind the complexity we see in this animal has to be behind the whole scheme of things, because you can't have this happening by random processes.
But Art, how then do you explain from the Genesis paradigm the fact that at these lower levels we don't have creatures that walk around? I mean, we have very, very complex and beautiful creatures, extremely complex, but we don't have there's a sorting, it appears, to have been done in those fossil layers.
There is, and it's not clear exactly why things are in the order they are, but it's clear that there is a movement from marine, ocean, to things that lived in underwater, to things that lived on land. And then at higher levels, things that could escape from burial in this water. So I think it's clear if we were to start covering up the earth today, if we were to have another flood, the first things that would be buried are the things that live on the bottom of the ocean, and then subsequently we would see layers of rock or layers of sediment that had things that lived higher and higher levels in the ocean. We'd get fish, and eventually we'd get things that lived on the top of the ocean, and then we'd get things that lived on land. And eventually, if the burial kept going, we'd find the remains of complex animals like us.
Okay, we have some time for discussion. What are your thoughts on what we learned today about the fossils, the records? I mean, we have to ask the question, I do anyway, Rondi and I talked about it on the way here. Why believe in evolution? I mean, they've debunked a lot of things, even today. You see the complexity at the very beginning, the earliest flood rocks. Why do they continue to believe and to continue with this hoax? I mean, we had an idea. What's the one thing you have to believe in, and to believe in the Genesis?
God's word.
God, exactly. They take God out of the equation, right? Because they don't believe in God. If these things are correct, in my belief, you had to have God. You had to have a universal being that's still there today that we have to be beholden to, apparently. That's just my take on it. Ronnie and I agreed on it. I think we're all probably in the same agreement in that, you know, these people don't want us to believe in God. And that's why it's taught in schools still, but there's no evidence for it. You can try, they have yet to find those missing links, as they call it.
It takes faith to believe it.
It takes faith. Correct, correct.
Takes faith to believe either one, you know, really, I mean, you have to have a lot of faith, it's, things
Well-
just kind of.
Oh, I think.
I mean, you're exactly correct, but the evidence that they're coming up with now
Yeah,
is really, really hard for evolutionists to refute. And that's why when we talk about another one that we're gonna, the ending one, where they wanted to take samples of rocks. And tell me if I'm wrong, Jim, because it's been a while since we heard about it. The park, the park people, I guess, the government that, you know, we couldn't take a rock out of the Grand Canyon. That was
No souvenirs.
a no-no. We could buy them at the local store for a lot of money if we wanted to, but we couldn't take a pebble or anything. We took a lot of sand with us in our sandals, but no rocks. They wanted to go in and actually do something, and I don't want to, they wanted to take some rocks out to show that they were still, when they were bent in certain ways, that they were still sedimentary rocks that were still soft and could bend that way, or were they changed by heat and the rest of them. So they wanted to take samples, you know, and do some scientific proof, and we'll see what they did for that. But they had to ask for permission to be able to do that. Well, they were, you know, there was a certain set of guidelines that they had to follow in order to do that. They did their work and said, this is what we're going to do, and sent it back. Well, they never heard back for a while, a long time. Then they came back and they said, well, you know, what's with our permits? Where were they? Well, they said they asked for more information. They gave them that information, again, stalled. They did that a couple of more times until they actually went with the Alliance Defense Fund and sued the Park Service for it. This is all 4 or 5 years. You'll hear them talk that it took like 4 to 5 years just to be able to do this. And what they had found, and it got all the way up to the in Washington DC, the National Park Service. They didn't want anything to do with it. They said, just give them what they want. And FOIA, they did some FOIA things afterwards, and they got the emails going back and forth between the people that were arguing about giving them that stuff. And they said, could you imagine what they will find in that record that will prove their point with their creationists? So they knew what they were going to do and what they were going to find, and that they didn't have an answer for it, that the creationists were going to find the answer for it. And I'm not going to spoil the last thing that we're going to watch, but they went in there and they found exactly what the creationists were looking for. Proof of a short Earth, or a young Earth. And that they just didn't want that to be done, the main paradigm. So that's what we're up against when we do this. But there are more and more creation scientists, the young kids today. There's more and more going out there and finding this stuff, because, you know, God wants you to find it. It's in what He did for us. But they still teach it. They still teach it in the archaeologists that your daughter-in-law is going through. They still teach that stuff, but they can't prove it now. I mean, just think of the things that we talked about with the genomes. You know, the complexity of it, and that, you know, that we had, I mean, they still tout that we come from apes. That's been debunked.
Well, it's been government-controlled schools.
Mhm.
Now that Department of Education is being dismantled and going back to the states, that's gonna begin to change in some states.
Yeah, and I've you know, talked with a lot of the homeschool groups here and said, you know, hey, this information is out there if you want me to give you our, you know, all of the DVDs and whatnot and stuff, and you can give you people to talk to and whatnot. Says, be my guest. I mean, it's here. we can begin teaching it, you know, because we have a leg to stand on now. Back in my day, we didn't have any, you know, way back when I was learning this stuff. Again, I say like probably most of us, I had faith that God created. And somehow, and because of all of that, my father-in-law was the same way. He believed that God created it, but he had to try to work in the 7 days or the 6 days of creation into a long earth. They weren't really days, like it says in the Bible that it was days, so that you had to kind of believe in the long earth that it was an eon or whatever kind of thing that they tried to suggest with this. But it's really nice to see, you know, like he said here, all of the complexities were there from the beginning. You don't see forms coming up from an amoeba to come up. I mean, where did the amoeba come from? You know, the single cell. So, what's that? I mean,
Primordial sludge.
The primordial sludge, yes, exactly. I mean, they've come up with a lot of different things. You know, the stars are predictably millions and millions and millions of light years away. The light couldn't even be here. You know, who did that? Well, God can do that.
But
And-
yeah, I was reading this one this morning.
Oh,
We're
did you?
certain that we can go faster than speed of light. It's gonna be a way, we're gonna find a way,
So we're gonna go warp speed.
we're gonna go warp speed, because we got to. It's in our sci-fi, so it's gotta happen.
It's gotta be there, right?
Self-fulfilling prophecy. So
And-
that
and
can
the
go
te-
faster than the speed of light, but light can't go faster.
But
And
we don't have Captain Kirk, do we?
Teleportation, well, he's yet to be,
Oh.
he's yet to
Mr.
be,
Scott first, I think.
yeah. Geordie LaForge and all the rest. I just find, I eat this stuff up. It just proves that God's here. In my mind, anyway. So. I've enjoyed doing this. I know Jim, we were just talking, Rondi and I, on the way in, Jim, we're gonna have to give him an account of our trip,
Oh, yeah.
because we haven't seen much of that, so.
Right.
Anything else this morning?
Day one, it was hot,
Yes,
and the river was cold.
yes. I mean, a total difference. I mean, 60-degree water, 110 upstairs. It was,
And then you get splashed real hard.
yeah, and then you get splashed and you're sitting there, you're actually shivering on the boat. There was one day that it actually rained hard.
Oh, we had a thunderstorm.
Yeah, came right down into the gorge. We saw the lightning hit.
Did you do a donkey trail? I mean,
No
great
donkey
donkey stuff?
trails. No. None of that.
No.
Parachuting.
It was, well, we helicoptered out. That was fun. Yep. But, it's a godforsaken land, as they call it. I mean, I don't know how the Indians made it, but they did. They did. Probably different weather back then, who knows? But it did rain hard. In fact, they said they didn't really talk about rain coming, but he said that day, he said, we're gonna hit a lot of big rapids today, so might as well put on your raincoat. And so we did.
Just before we hit the big rapid.
Yes,
We hit the thunderstorm.
yep. So. But it was a fun trip. Look forward to, we'll have to get together and look at our pictures. I know you got a lot more, but you were in the back there. You didn't get splashed as much.
Yeah. I think once we-
I figured you did, yeah, you did up front. So, okay, well, we're gonna get out a little bit early. Except,
2 minutes.
yes,
Can you please pray for Jean's husband?
yes, I overheard. She was, your husband had just fallen or something?
Yeah, I'm being good off.
Okay. Okay, let's go to Lord in prayer. Heavenly Father, we thank you, Lord, for what we learned today and what, about your wonderful creation and the flood that you, brought to us. Help us as we go through today's service that, we hear what you want us to hear. And we also ask for special prayer for, Jean's husband, that the fall that he just took today, that, it's not too serious. And, we ask all of this in Jesus' name, amen. Thank you all.